Welcome to this video where we're going to explore 2D navigation in Godot, showing you how to get a ship navigating automatically around obstacles. We'll start with a basic setup and then we'll work our way up to a full system with pathfinding and collision avoidance. So let's take a look. If you want to follow along with me, there's a starter project on Git. There's the link in the description. I'm going to get myself a zip of that, download it, extract it, drag and drop it into the Godot project manager and start the project. Looking at the project itself, we have some assets, which are some visuals, a tile map resource, then we have some scenes. We have an iceberg scene, which at the moment is just a simple sprite and points. Later it will become an obstacle. We have a ship scene, which we're going to use to navigate around the map. Then we have a waypoint scene, which is a very simple marker and sprite. And finally, we have the actual map, which is a tile map upon which we're going to navigate. The assets used here are the famous Kenney assets. You can find those in the link in the description where you can go and download them and use them for free. Or if you'd like to, like I did, you can buy the bundle and donate. Things should be configured that you can just press play to run the project. And when you do, you should see our map in the window with our ship sitting somewhere on the top left-hand side. What we're going to do in this video is we're going to get this ship navigating automatically around this map. Navigation in Godot involves just two nodes, a navigation region 2D, which we use to define the movement area, and then a navigation agent 2D, which we can attach to any object that we want to be able to navigate around that movable area. If we want to navigate, say, on our map, what we do is add a navigation region 2D to the scene, and then we can draw our navigable area. Then we add our ship onto the region, attach a navigation agent 2D to the ship, and we're ready to start navigating. So let's start by creating our navigation region. In the map scene, I'll select the navigation regions node here, and then instantiate a new navigation region 2D. When we do that, a new toolbar appears with three buttons for drawing a polygon, a bake navigation polygon, and a clear navigation polygon. Let's draw ourselves a polygon by clicking on the right-hand side in the empty, selecting new navigation polygon. Then we can use the left mouse button to draw a polygon, and when you close the shape, you should see a coloured region appear. This is the baked navigation map, is the actual surface upon which your navigation agents are going to navigate. The baking happened there automatically, but this isn't always the case. If it hasn't happened, you can click the bake navigation polygon. If that still doesn't do anything, you can try clicking the clear and then the bake navigation polygon. If you still don't see anything, it might be that the area is hidden behind the water. So you can click the eye on the left-hand side to unhide the water, and then hopefully you'll see the region behind there. Hopefully though, you do have a baked navigation region as I do here. If you're using your own project or you've played around with this before, you might notice the colour of my region is different to the default colour. The reason this is a default colour is a light blue, which clashes with the water. You can change the colours by going to Project, Project Settings, General, switching on the Advanced Settings, and down the left-hand side you can go to Debug Shapes, and in the Navigation section there's the Geometry Edge Colour and Face Colour. And you can see that I've set that to 802 BFF. You may have noticed a slight gap between the baked area and the polygon. This is the agent radius setting that you can find in the inspector under the navigation polygon in the agent section. You can set this agent radius. The agent radius tells the navigation system how much space your navigation agent actually needs. You can use that for making sure it can get through tight spaces or navigate around corners correctly without cutting them off. If I set the value to 30 and bake, you can see that the gap between the polygon and the actual baked area becomes much bigger. This allows a lot of flexibility. For example, if I set this to 70, a very large value, you can see how tight the navigation mesh becomes. I'm going to set it back to 30. I think that'll do for our map. Now, rather handily, Godot provides us a way to see our navigation regions whilst the game is actually running. To do this, you can go to Debug, select Visible Navigation Shapes, and then select Play to run the game, and you should be able to see your baked navigation region whilst the game is running. And now that we have our region, what we want to be able to do is navigate, and that involves setting up the Navigation Agent 2D. The Navigation Agent 2D node comes with a lot of built-in functionality for navigation. There are three main functions that you'll use on this: the isTargetReachable, the isNavigationFinished, and the isTargetReached. Before you start navigating, the isNavigationFinished will be true because we're not navigating. TargetReachable and TargetReached will be false. To navigate with the Navigation Agent 2D, first of all you assign a destination, for example by clicking on the map. When you've done this, you set the target position of the Navigation Agent 2D to wherever you've clicked in this case. Doing that will cause the Navigation Agent 2D to ask the NavigationServer for a calculated path. When this happens, there'll be some updates to the state. The target reachable will be updated depending on whether we can reach the target. The isNavigationFinished will now be false because we're navigating, we have a path, and the isTargetReached will be false, assuming that your point is far enough away. We then navigate along the path by each frame asking the Navigation Agent 2D to get to the next position along the path from where we are. When we've got that position, what we do is we get the direction to it so we can orientate ourselves, multiply by our speed, and update our current position. In other words, we're just going to walk along the path, each frame asking the Navigation Agent 2D which direction we should be going in. Eventually, with a bit of luck, we'll reach our target. The isNavigationFinished will now be true. The The target reachable will still be true or false depending on whether we could, and the target reached will also be true or false depending on whether we manage to reach the target or not. In our case, we could reach the target, but you will have cases, for example here, where maybe the target is outside the navigation region. You'll know this because is target reachable will then be false. We'll then navigate as normal, and the navigation finished will be true when we get as close as possible to the target, but the target reached will be false. Now we've seen the outline, let's go and implement this in the code for our ship. In the project, I'm going to select the ship scene, select the root node, and then add a new NavigationAgent2D. In the inspector, you'll see three main sections, Pathfinding and Avoidance, which we'll look at later, and also a debug section. If you open that, I'd like to enable debugging so we can see the paths plotted by the navigation agent when the game is running. In addition, I'd like to customize the path a little bit, so I'm going to click the Use Custom Path, then select a color, a dark blue, and change the width of it to 2 pixels. Then let's open up the script for the ship. There's already a little bit of pre-prepared code in here that's just selecting a random texture. Let's grab ourselves a reference to the NavigationAgent2D, and I'm going to shorten the name there to Nav2D. Then we'll add in a variable for the speed and set that to 100. Scrolling down to the bottom of the code, let's add a function called manual navigation, where we're going to detect a mouse click, which is set target in this case, and if we do click the mouse, we're going to set the target position of our navigation agent to the global position where we click the mouse. The set target input has already been set up in the pre-prepared project in the project input settings. Then to use this, let's add a call to manual navigation each physics process frame. It's worth noting we're using physics process and not process. Godot recommended in the documentation for navigation you use physics process so that you have a regular interval between frames. Now we have the target set, we also want to be able to navigate. So we'll add a new function called navigate, taking in our delta. The first thing we'll do is check if the navigation is finished. If it is, then we'll return because we don't have anything to navigate to. Otherwise, we'll get the next path position by asking our agent for the next path position. Once we have that new position, we can get the direction to it from where we are, multiply that by our speed, and that's our new velocity. Then we can update the position with this new velocity and also rotate our sprite. Then we can invoke this below manual navigation inside the physics process. Next, let's jump into 2D view, and I'm going to make the debug label visible on the left-hand side. With that visible, I just want to move it up a little bit because I'd like us to see 3 lines of debugging information whilst we're navigating. Back in the script view at the top of the physics process, we'll just update the debug label each frame with some text telling us whether the navigation is finished, the target's reached, and whether the target is reachable. With that done, we can go to the map scene, run the game, and you should be able to now click around the navigation area and navigate to the points that you've clicked. And also if you click off the region, you should notice that it'll tell you that the target is not reachable, but still finish the navigation. When you've finished having a play around with that, let's drop into the ship scene and open up the pathfinding section. Let's set the target desired distance to 100 pixels. The target desired distance is the distance that the agent has to be within to consider itself having reached the target. If we now run the game, you can see the quite dramatic effect of this setting. We're stopping way before the target that we originally set, but this allows a lot of flexibility. I'm going to go back actually and set this by default for our game to 30 pixels. Whilst we're here, there's another important one, which is called the path desired distance as well. If I run the game with the setting at 20 pixels, and just make us go down the side of the region here, you can see we stick very close to the edges of the region and very close to the path itself. If I change this value, however, to 100 pixels, you'll see that it optimizes the path by cutting the corner off. So long as it stays within this path desired distance, it'll make the path as optimum as possible. So you can use these 2 values to really customize the behavior of your agents. The path max distance is the maximum distance that we're allowed to stray away from the path before a new path will be calculated. You'll typically see this used when your agent is trying to avoid something and it strays too far from its path. It'll then get a new one calculated for it. And whilst talking about distances, let's reset the path desired distance and set it to 30 pixels. I think that should be okay for this demo. Going back onto our map, I'm just going to extend the region a little bit. So our region is now covering the island. If we run the game, you'll notice when we navigate though, we have a tiny bit of a problem. We're able to navigate over the island. And we don't want to do that. We want to be able to navigate around it. Now there are a couple of ways of doing this. The first and most common way that I'd like to show you is using a polygon 2D. So I'm going to add a polygon 2D as a child to the navigation region. Then it's simply a case of drawing a polygon around the particular region that you'd like to cut out. Then hit bake and you'll see that the polygon is cut out of the navigation area, also with the agent radius taken into account. So if you now run the application, we're navigating around the island. The polygon is however white. That might not be desirable. You can simply set the color to fully transparent and then you won't see the polygon on the screen. Being able to cut regions out with the polygons adds a lot of flexibility. And talking of flexibility, you're not restricted to just one navigation region. We can use multiple regions. So let's delete the original map that we have inside here. Add a new one in, and I'm going to make a map here with a deliberate gap at the top of the island. With that done, I'm going to add a second navigation region 2D and put a piece in the gap, deliberately leaving some space either side. This second navigation region is also something upon which we can navigate. However, if you run the application, you'll notice there's a problem. We can't jump across the gap, so we're unable to navigate onto it. To be able to navigate across regions, you need to be able to connect them together. I'll zoom in here and try and get these to connect. Now, in theory, you should see a visual feedback inside the IDE when they are connected. However, in my experience, that's a little bit hit and miss. So I'm actually going to run the application and see if what I have here is actually good enough for a connection, and no, it isn't. So I'm going to go back into the game and try and make it a little bit more accurate. Let's run this again. And despite them being very close, I still don't have a valid connection. Now, when you first start using navigation regions, this can be a little bit frustrating, but there is actually a setting to determine how close they need to be for a connection to be made. If you go into the project settings and then into general, on the left-hand side in the navigation 2D section, you'll find this default edge connection margin. This is in pixels. I'm going to set this to 20, so much, much bigger. With that said, there's still no visual feedback in the IDE, however, I'm pretty sure this will connect. So let's run the application, and indeed you can see there is a connection now. There's this faint purple line, and we can see these semicircles which indicate our connection radius. Now the connection has been made, we're able to navigate across the two regions using this connection. Likewise, I can do the same with the other side and drag that up to the other navigation region, and here we do get the visual feedback. There's a very, very faint purple line there, if you can just see it, and if I run the application, we can now navigate across this connection as well. Another important feature of navigation regions are the enter and the travel costs. The travel cost is the one that's more commonly used. Both of these apply a penalty to either entering or traveling across one of the regions. This can be really useful, for example, in a driving game where you have asphalt and gravel and mud. You can have a higher cost to travel across gravel than you do asphalt, and then even higher cost, for example, for mud. These travel costs are then built into the calculation, and Navigation Agent will try to choose the path that's quickest rather than shortest. We can demonstrate this by setting the travel cost to 100 here, and if you run the game and set a target to the other side of our region with a cost of 100, you'll see that the Navigation Agent has actually decided to go the quicker but longer way. So I reset that back to 1 because I definitely don't want it to be 100. Another aspect that's important to take note of is navigation layers. You can use the navigation layers just as you use layers and masks with collisions or something like that. In this case, use it to tell the navigation agents which navigation regions they can actually navigate on. So if I set this navigation layer, for example, to 2 here, our ship is no longer able to navigate across because its navigation layer is set to layer 1. It's not set to layer 2. If we add layer 2, we're now able to navigate across. And I'd like to show you a subtle but really important bug with the navigation layers. With both layers 1 and 2 selected here, if we run the application, you'll notice that done is false rather than true. So it's saying that it's navigating in some way despite the fact that we haven't set a target. If we go back and turn off layer 2 and leave it back to how it originally was with layer 1 and run the application, now by default it's set to say that it isn't navigating, so it is done. If we set layer 2 on its own, we still have the same problem as when both were selected. By default it's set to navigating, which is not correct. We haven't set a target yet. Now this isn't a deal breaker by any means, but depending on how you're setting things up, it could cause unwanted behavior in your application. It's also labeled as a bug on GitHub, so I'm sure the team will fix it at some point. In the meantime, I'll set the layer back to 1. Then back in the map, I'll also set the navigation layer of our second region to 1 as well. Connecting the regions up side by side is not the only way of navigating across regions. We can also use something called a navigation link. I'm going to adjust our region so we're quite far away from our original navigation region, run the application, and make sure that we can't navigate across. Despite these regions not being connected, we can use another node called a navigation link 2D. And this node can be used then to connect regions together from big distances. With this navigation link 2D added in, I'm going to find it in the top left at 0 by 0. Now when you change the position of this, be careful. Don't click the middle of it to move because that will actually start setting it up. I'm going to click the red arrow here, which is in the X, drag that across, and then the Y arrow to drag it down. And now with the mouse, I'm going to select the top with the left mouse button. And as I drag that point, you can see the start position changing, which is relative to the position of this particular node, and drop it on the first region. Then I'm going to click the middle again to get the other point, the end position, and drop that to the other region. That's now made a link that we can navigate across. And we can see this working when we run the application. An ideal use case for this, for example, would be a bridge. So I'll delete the navigation link because we don't need it. And when I do the delete, you'll notice that the navigation region has disappeared. I'm going to delete the second navigation region as well. Then I'm going to select the original navigation region, which we can see outlined here, and hit bake, and hitting bake seems to have had no effect. Well, it has actually happened, it's just being drawn behind everything else. If I hide the water, you can see that we do have our baked navigation area. Now, I did mention that these nodes are experimental, and you're going to find when you start using them that you do get little quirks like this. So for now, I'm going to leave the water hidden so that I can see the navigation area. Now I'd like to turn our attention to navigation obstacles. These have two main functions. They either provide a blocker that the navigation agents have to find their way around, or statically they can carve themselves out of the navigation region. Now we can already do this carving with the Polygon 2D, and the Polygon 2D offers better performance because it's a simpler object, so usually that's used when it comes to carving. Nevertheless, I do want to demonstrate this to you. So with the navigation region selected, I'm going to add a navigation obstacle 2D as a child to this, and then use the mouse to draw a small polygon. With the polygon drawn, if we run the application, you'll see that we can still navigate through it. There's no actual blocking or avoidance or anything going on. To get it to work, we have to carve it out of the navigation region. You can do this by selecting the node, then on the right hand side in the navigation mesh section, checking the effect navigation. When you then bake, you'll see the area cut out of the navigation region just as it was for the polygon, taking into account the agent radius. Selecting carve navigation as well also cuts a region, but this ignores the agent radius. Usually though, you would use a Polygon 2D for this. Where navigation obstacle 2Ds really come into their own is actually in avoidance, and that's what we're going to do with our icebergs. So let's delete this node. Let's open up the iceberg scene and add a navigation obstacle 2D as a child. Let's rescale the sprite. It looks a bit too big, so I'll set that to 1.2. That's a bit better. Then select the navigation obstacle. Let's adjust the radius to around 50 pixels. When doing that, you can see this orange circle. This orange circle is what the navigation agents are going to try to avoid when they're navigating around the map. And the great thing about this node is you can actually move it around your map. The agents are then aware of where it is and they will adjust their paths dynamically accordingly. To show this, let's go back to the map and actually instantiate an iceberg as a child of the obstacles node. Then if we run the application and try and navigate through the iceberg, you see that we seem to navigate through the iceberg. There doesn't seem to be any avoidance going on at all. The reason for that is by default, navigation agents don't have avoidance set to on. The reason for this is because it's computationally more expensive than with it off. So let's go back into the ship scene. With the NavigationAgent2D node selected, we can open up the avoidance section and set avoidance enabled to on. Now the avoidance works a little bit like move and slide with the physics. We set a desired velocity, so on the navigation agent we set a velocity, and then it takes into account the obstacles that it needs to avoid and adjusts the velocity accordingly. To get this velocity, we need to connect ourselves up to the velocity computed signal. This will be emitted once the navigation agent has calculated its safe velocity. In other words, a velocity that's not going to hit the obstacle it's trying to avoid. With that connected, I'll make myself a little bit of space. And inside there, we're going to update our position using the safe velocity, that's taking into account avoidance, multiplied by the most recent physics delta to normalize for time. At the same time, we'll also rotate our sprite. And now we're setting our position there, we need to change the way we're navigating. So you can keep the original function. Let's make a new function called NavigateSafe, which takes a large chunk of navigate. We're just making a small adjustment. Once we've got the new velocity we want, we set the nav2d velocity equal to that new velocity. That will set off the calculation process, and then once that's done, the signal will be emitted, and in there we can use the safe velocity to set our position. What we shouldn't forget though is to actually invoke this in the physics process instead of the navigate. With that done, we can go back over to the map, and if we run the application, you can see the ship is now actively avoiding the iceberg. It is, however, very close, and we can customize that. If we go back into the ship scene and change, say, the avoidance radius to 50 pixels, you'll see now if we run the application, it takes a much wider berth. The iceberg though is static, so let's jump into the iceberg scene. And if you open up the script view, we've got most of the code already inside here. The iceberg has a couple of children, which are points. We immediately inside the ready get the global position of those points. And then down inside the process, I just want to add a little bit of code inside here to get us moved backwards and forwards between each of those points. So we'll set the direction that we want to go is the direction to the current target. We'll move according to our speed multiplied by delta. Then if we're doing a certain margin of the target, then we'll switch the target round to be target 1 or target 2, depending on what we were just heading towards. Then we can go back into the map, right click on the iceberg, select editable children, and then we can use the move tool to set the points wherever you want them to be. And if we run the application, you can now see the real power of the navigation obstacle. The ship is able to adjust its path and move around it even though the iceberg is moving. Now we've covered most of the navigation features, but there is one thing outstanding that you'll need to see. The ship scene as it is an area 2D, but I know in many of your games you'll be using the character body 2D. So what I'd like to do is demonstrate how we can integrate that. What we'll do is make another version of the ship scene as a character body 2D. So I'm going to open up the ship scene, do scene and save scene as, and make a new folder called ship CB and save that as ship_CB. Then I'm going to right click on the root node and change the type to a character body 2D. Now we need to create a new script, and the code is almost exactly the same as the existing code. I'm going to select all of this code by doing Ctrl and A and then Ctrl and C to copy, then disconnect the current script from our character body 2D and add a new script with the object empty template. I'll paste the code into the new script and then go to the top and remove the extends area 2D. Now we need to set up the movement. This is a physics node, so we shouldn't adjust the position inside our code. We need to let the physics engine do it. A character body 2D uses move and slide. We'll start off with the non-safe navigating. So I'm going to uncomment navigate delta and comment out navigate safe. Then inside the navigate function, going to switch out the var new velocity vector 2 for just velocity, which is the character body 2D's velocity, then replace the position line with move and slide. Then we want the sprite holder's rotation also to use the velocity, and I'll move that to before the move and slide so it uses the desired velocity. For this to work, we need to remember to select the Navigation Agent 2D on the left hand side and turn off avoidance on the right hand side. With this done, we can jump into the map, remove the existing ship and add in our new character body 2D ship. And then when we run the application, we'll find ourselves navigating. It's just there's no avoidance because we've turned it off, but everything else should be working okay. Now let's get the safe navigation working. To do that, we can comment out the navigate delta and uncomment the navigate safe. Let's go down to the signal and we can remove the position setting line and replace that with our velocity is equal to our safe velocity. Underneath that, then we can invoke the move and slide, and that's all we need to do. We can re-enable avoidance, run the application, and we should see that the avoidance is working just as it did with the Area 2D version. Now you will see that the sprite rotation is a little bit jerky, so I'm just going to update the code and lerp the angle rather than it being instant. Running the application, that looks a little bit smoother, well, to my eyes anyway. Now we have more or less everything set up, so to finish off this video, what I'd like to do is just set up a little bit of a level that some ships can navigate around. So I'm going to do a time lapse here, adjust the region a bit, add in some waypoints and some icebergs. So with some waypoints and some icebergs added, what I'd like to do is just alter the code of our ship a little bit, just so that it automatically navigates between random waypoints. To start off then, inside the script for the character body ship, I'm just going to move these constants actually to the top of the file. I think they're better off there. And then we can add in a couple of exports for a minimum and a maximum speed. Then inside the setup, we can set ourselves with a random speed as soon as the scene is instantiated. Next, what we'll do is we'll add in a couple of variables. One will be an array or a list of our waypoints. The other one will be the index of the current waypoint that we have selected. With this done, we can drop down into setup, and inside setup, what we'll do is we'll grab all of the waypoints that are inside the tree and add them to our list. Then there's a little bit of protection. We can just say that if there are less than 2 waypoints, we'll queue 3 because we need at least 2. If that's okay, we can invoke setNextWaypoint. That doesn't exist yet, so we'll define it below here. This is a very simple function that simply picks a new index at random that isn't the same as the current index that we have, and then sets the navigation agent target to this waypoint. Then inside navigate safe, instead of returning if navigation's finished, we can invoke our setNextWaypoint. Whilst we're here, we can clean things up a little bit. We're no longer using delta inside navigate, so we can get rid of that. And then inside the physics process as well, we're not using delta there anymore, so we can underscore that as well. Then let's drop back into the map. I'm going to unhide the water so we can see it and turn off the visible navigation. And then I'll also turn off debugging on the ship as well. And now if you're in the application with a bit of luck, we should see our ship navigating between the waypoints randomly and also avoiding the icebergs. However, as we run the application, you might have noticed in the debugger there is an error. And if we open up and look at that error, what it's telling us is that the navigation server was not ready yet when we asked for our first path to be calculated. To prevent this happening, we need to induce a little bit of a delay when the ship first loads. The Godot documentation actually provides an example code to do this. However, I find the code is not always reliable, so I'm going to do things in a slightly different way. Let's drop back into the ship. Inside the ready, as soon as we're ready to go, we're going to set physics process to false so that physics process is not invoked. Then we'll add a tiny function called lateInit where we're going to set the physics process to true. Then at the end of the ready, we'll defer a call to lateInit. So that's going to happen at the beginning of the next frame where we're going to set physics process to true, which means the following frame will actually have the first invocation of physics process. That should give the navigation server enough time. And indeed, if we run the game, we don't get the error now in the debugger. And with that said, I think we're pretty much done. I'm going to go away now, add some more ships to the map, make some tweaks to the map as well, and I'll see you in a moment with the full map up and running. And here we are with a few more ships navigating their merry way around the map, hopefully avoiding icebergs and avoiding each other. Congratulations on making it to the end. If you're still here, that means either the tutorial was actually helpful or maybe you fell asleep with the autoplay on. If you did find this video somewhat enlightening, then a like would really be appreciated because it always helps. Next up, a mini-series where we'll be taking our Mixamo characters to the next level, bringing them to life with finite state machines and watching them battle. And if you got stuck somewhere or you have ideas for other tutorials, then please drop them in the comments below. There's more Godot content coming soon, so hit the subscribe button if you want to be kept up to date, and I'll catch you in the next one.